Question number 1 on the fall 2017 final exam for Math 1050 gives us an equation in general form for an ellipse, and we need to complete the square to find the standard form, and then write the equation in standard form so that we know what the center is and can easily graph it. Okay, we're going to start by grouping our x terms together. So anything that has an x in it, we'll put those together. And then anything that has a y in it, we'll put those together. So you can see how I'm just swapping the order of things. And then I'm going to go ahead and put the constant on the other side. So far I've got my x's together, got my y's together, and I have my constant on the other side. Okay, next we're going to factor out the coefficient from the squared term. So 4 factored out of 4x squared is 1x squared. I don't need to write the 1. Negative 8 divided by 4 is negative 2x. Now here I'm going to be completing the square, so I'm going to leave space for that. Then for the y values, I can pull out 9, which leaves me with y squared, and then 9 divides into 54 6 times. See in there yet. And then, of course, this equals that negative 49 I put on the other side, which right now, a negative number over there doesn't make sense, but don't worry about it. It's all going to work out. All right, to complete the square, we need to half the negative 2. So negative 2 divided by 2 is negative 1, and negative 1 squared is 1. So we're going to add 1. However, we are adding a value of 4 times 1 because that 4 out front gives the 1 that value in the overall problem. So we need to add a 4 to the other side to balance out adding that 1. Next, we have 6. We're going to do half of 6, which is 3. And square the 3, which is 9. So we add 9 here. But we're not adding 9 in the overall problem, we're adding 81 because it's the value of 9 outside of the parentheses times the 9 inside of the parentheses. Okay, now we have 4 times x minus 1 squared. Minus because that's minus, 1 because that's the number we got when we halved it. Then we have 9 times y plus 3 squared. Again, that was the number we had when we halved it. That's our binomial squared that would give us this perfect squared trinomial. Okay, and then on the other side, if we combine our negative 49 and 81 and 4 together, that's a negative 45 plus 81. Know if I want to do that math in my head right now. Simply I'm tired today, and why bother? I've got a calculator. Okay, so I got 36. Hopefully you guys have that too. Now remember, when we put our ellipse in standard form, we want a 1 on this side. So at this point, to get a 1 over here, we need to divide everything by 36. Okay, now we can reduce. So reducing our 4 into our 36 is 9. So we get x minus 1 squared over 9. And then 9 goes into our 36 4 times. So we have y plus 3 squared over 4. And then of course we have the 1 over here. And this matches our standard form of x minus h squared over a squared plus y minus k squared over b squared, which equals 1, right? Made it match. So we're in standard form. We have a center at 1, negative 3. This, of course, is an ellipse. If we wanted to graph this, it would go 1, negative 3, And then A direction is 9, so the square root of 9 is 3. So 1, 2, 3 that way, and 1, 2, 3 that way. So those would be our vertices. Let's figure out where those are. So that looks like 4, -3, and -2, -3. And then the endpoints of the minor axis are going to be 2 from the center this way and this way. So here's our ellipse right here. Unless they ask us to find the foci, we don't really need to, because it's not actually part of our graph or part of our equation.